see.
Good evening, everyone. We are from Group 2, and today we're going to be talking about machine learning in biology and medicine. Machine learning has become a very common technology in the new era of computer and artificial intelligence, and its usage in medicine and biology is growing day after day. And today we're going to discuss some of the common machine learning methods which are used, and of course the three main methods which are used in biology and medicine and how they're applied to this field. To start it off, I'm going to pass it on to my colleague, Mr. Husband, and he's going to tell you about machine learning a little bit.
Okay, thank you, Sahur. Okay, now I want to start saying that this article is talking about new technology discovered of area biology and medicine, especially in exploring new generation sequence NGS technology and multimodal imaging, imaging and clinical practice and research as recovering electronic health record. And thus, it play a role in the function of machine learning (ML) algorithms on a large scale in heterogeneous data such as the clinical imaging and genomic data and present to researchers to gain understanding on the based on genetic disease. Thus, in define the optimal therapy approach. However, it is a challenging loaded problem with and how and is solved them. So, three basic types of machine learning strategies in ML, that is supervised learning, unsupervised learning, and reinforcement learning (RL). In supervised learning, this method can be used to the using the sample in non-class level training data to predict the class of new sample. Thus, the process of supervised learning is means the classification when the output label are categorized and a call is regression when the output is continuous. Also, the supervised learning algorithm is example of linear and logistic regression. Furthermore, supervised learning equals where the rise the performance of the classification model is classified into new sample and cross-validation are where accuracy to test the model ability to predict the new data and not use accumulation. And to offer the sign into how they generalize the model to the independent data set. Then a constitution cross-validation where it is shown the hyperparameter of the classification model to overcome the problem. So, supervised learning is method is successful when we design a progenetic and predictive biomarker that is one example of this study. There's also the approach of using a derived progenetic marker is main major effect of the research findings. So I will be giving the Sarah about the unsupervised and learning.
That was very interesting. Thank you very much. And now we'll hear from Sarah about unsupervised learning. Can you tell us what it's exactly all about?
Know about the unsupervised learning. So, unlike the supervised learning, the unsupervised learning specializes in drawing inference from samples based on its organization and association table. So, the supervised learning, as I mentioned before, we're going to have actually labeled data, and there will be guidance on the supervised learning in order to get the information. However, in the unsupervised learning, the machine itself is going to get the information based on the supervised learning, which are process association analysis allocates the sample into different groups of similar features. So an example of cluster algorithms are k-means and self-organizing maps. For the association rule learning, it finds the relationship of variables via specific measures of interest. It has been used in order to detect comorbidity and multimorbidity in old age. Now I'm going to talk about reinforcement learning. So what's the difference between the reinforcement and the supervised and unsupervised? So the reinforcement learning is concerned with learning how to make multiple decisions in order to optimize long-term effect via adapting to a new environment. What does that mean? So basically, you're gonna put the IA machine into a new environment that it's never been put in before. So based on this new environment, it's going to adapt to the new surrounding and it's going to produce certain actions. By producing this certain action, it's going to discover the errors and reward obtained from these actions and use it as information. Now, the reinforcement learning is not, it's between the unsupervised and supervised learning. It's not supervised because it's not supervised because it doesn't rely on specific labeled set of data, and it's not unsupervised because it performs multiple actions in different situations in order to optimize the effect. So now I'm going to pass the discussion to Farhood as he's going to talk about the other forms of machine.
All right, thank you very much, Sarah. So, as mentioned earlier, these were the three main types of machine learning protocols which are used in biology and medicine. But apart from these, we have other types of machine learning which are becoming more and more commonly used, and we're going to discuss some of the more prominent ones. To begin with, we have text mining. Now, text mining is a bit of a very, it's a bit of a complicated yet useful software. It allows us to find information and data from very large databases containing millions and millions of articles and journals, which are, by the way, a gold mine for the medical community. And if you want to do it manually, this is going to take a very long time. Finding the data is one problem, and but constructing the database itself is another problem. It's a very long process, and then there's a lot of data information which, if you want to sit down and do it manually, it's going to take forever. So what to do? We came up with software such as NLP, natural language processing, which we use it to create the structural information from a completely disorganized system, curate them, then categorize them accordingly. Then we can use the algorithm to run predictions in terms of disease progression and toxicological studies. So that is the benefit of the system. However, there is one downside, and that is that it needs to be constantly updated because, of course, databases are always frequently updated with new research and new data being published. So the algorithm as well must be constantly updated so they can learn to process the new information. Moving on, we have a very prominent method known as deep neural network, also known as deep learning. Basically, it uses artificial neural networks, such as the neural networks in the brain, but instead now this is employed in artificial intelligence, and its function is to receive information, process it, and then give an output. And it's become very popular in medicine, especially the CNN, which is convolutional neural network, is another type of DNN. The only difference is that CNN, it enables the visual presentation of data. For example, in clinical settings, we can use CNN to visually present a genetic sequence and allow us to detect any mutations inside that genetic sequence. So it's quite a useful software to have. But of course, there is with every good side there is a downside as well, and that is the black box feature. The black box feature is that we don't really understand how the machine learns to make decisions. So we know that we give it information, it processes it, and then it gives an output. But we don't understand how it's processing that information and making decisions. Um, but there are ways which we can tackle this, of course, and that is repeated learning, such as the humans, how we repeat an action many times, eventually it forms connections in the brain. The same thing can be applied to the machines. And there's one major difference between machine and humans, and that is what makes us superior to AI actually, and that is what we call lifelong learning. This is another method which we're trying to improve implement in machine learning, but it's not been done yet because it's quite difficult. What is lifelong learning? Lifelong learning is when you continuously learn from from your environment. For example, you see something and then you learn to do it on the spot without having any prior knowledge about that input. So that is what we call as continuous learning or lifelong learning. It allows you to process new information on the spot without having any prior knowledge. But machines, they're a bit different. If in order for them to receive the information, process it, and then execute and then give an output without having learned it prior to the input, it's going to take a lot of training programs. And it also depends on the complexity of the algorithm. And this is quite complex in biomedical research and medical research because the inputs we have in our research is a lot and it's quite complex. So the algorithm will be complex as well. So we have to still achieve this, and there's still some debate because people will debate that if the AI, artificial intelligence, cannot have this lifelong learning ability, then they're not smart after all. So there is some discussion going on. And now I'm going to pass it on to my colleague Linish, and he's going to discuss the applications of ML in medicine and biology.
Okay, you guys can hear me, right? Hello.
Yes, yes, we can hear you.
Okay,
You're clear.
for the application, based on my colleagues has explained earlier, we can see machine learning plays a huge role in virtual personal assistants, predictors, in communication, video surveillance, social media services, email spamming, online customer support, product recommendations, and also online fraud detection as well. But we have to know data sets play a huge role in producing this productive model. But we have to agree that the randomization in this data is very, very important because it can lead to bias in ML. So in order to reduce bias, we have to always focus on randomization. For instance, in this medical environment, so in order to achieve it, maybe we can should take sample from different gender, culture, or races, so that we don't like really uh, can focus on reducing bias. And then furthermore, researchers who involved in this usually producing algorithm will be emphasizing on mainly on reducing bias, because if this bias is not overcome, it can lead to serious issues, and it can hugely affect the outcomes as well. So one of the example we can see in the bias in machine learning is the correlations offender management profiling. So this can lead to unethical issues as well. So for instance, in the treatment of coronary heart diseases, we can observe that gender bias uh, influence the outcome. But what we can know is that ML approaches with the use of data sets can cause a better policy making, because they don't like when they overcome the bias, then the policy they're going to make will not affected by bias. And then modern ML algorithm usually require more data collection for learning processes as well. So in addition, personal information must be kept confidentially. If not, it will be like pass it around, which is must get the concern of the people first before their information is passed around to other people. So the only solution for this matter is that they must limit the access to the data to any unauthorized party. And then recently, there are certain approaches that can be used to identify and eliminate the problem of bias in machine learning system by designing algorithms that can detect the bias. Because we can, as explained earlier, we can see machine learning is a very important tool. But since bias is one of the issues is upcoming in these things, so if we can overcome the bias, then I'm very sure it can play a very important role in the medical system. So to conclude, basically, machine learning plays a huge role in the current and also I'm very sure in the future healthcare system. So and this will be accompanied by generation of data for better models production, and also continuous learning algorithm will definitely help to do better in future as well. So what we can basically get the idea is the collaboration of medicine and biology will eventually help to overcome multiple diseases, which are really dangerous and threatening as well nowadays. So the role of machine learning will eventually help us in overcoming all these medical related issues. So
All right.
that's all from me. Thank you.
Thank you very much, Linish. That was very insightful information on the applications of machine learning, biology, and medicine. So I guess that brings our discussion to an end on this topic. So what we can take away is that machine learning is still in the process. Artificial intelligence is advancing day after day, and we have to constantly keep ourselves updated on how they have made advances. And we still have to achieve some things such as lifelong learning, which is basically what separates man from machine. And on that note, I hope everybody has a good night. A good night. It's night time right now, so thank you very much for listening to our discussion, and goodbye.
Bye.